Good afternoon, everyone, and thank you for joining us. The New York State Energy Research and Development Authority and the New York State Department of Public Service welcome you to this public webinar relating to the offshore wind interconnection into New York City. I'm Gregory Lampman, the director of NYSERDA's offshore wind program, and it's my pleasure to be joined here today by Liz Grisaro from the New York State Department of Public Service and representatives from Avangrid, the New York Power Authority, and Rise Light and Power. Unfortunately, the Embark team, who was going to be presenting with us today, at the last minute had an unavoidable conflict and will not be presenting here today. The purpose of this webinar is to provide a forum for these teams to present their proposed solutions for the offshore wind interconnection into New York and to provide webinar participants an opportunity to ask questions of the presenters. Each of the teams has been provided the opportunity to present their respective projects for 30 minutes, which will be followed by 15 minutes of Q&A facilitated by the Department of Public Service. But before I turn the webinar over to the first team, a few process reminders for participants. Can I get the next slide, please, Sal? First, if you're experiencing any technical issues, please contact Sal Graven at the email address at the bottom of this slide. This webinar is being recorded, and the complete recording will be available on NYSERDA's website under Offshore Wind, Focus Areas, Transmission, and New York's Electricity Grid, or you can find it simply by Googling NYSERDA Offshore Wind Grid. All participants have been muted upon entry. We've allotted 15 minutes for Q&A following each presentation. Please use the Q&A function to submit your questions to speakers at any time. The questions will be asked by staff from the Department of Public Service. We will endeavor to answer as many questions as we can within the allotted time. We do please ask that you identify the team the question is intended for when you submit the question. And please be sure that you direct your question to all panelists, not to a specific individual. Can I get the next slide, please? Again, we're going to work through the agenda in this sequence. So we're the welcome slide now. We're going to move to Avangrid, and then followed by a presentation from the New York Power Authority, and finally finish off with Rise Light and Power. Can I get the next slide, please? So presenting first today is going to be Avangrid. Presentation will be provided by Sebastian Libatati, Vice President for Business Development, and Fernando Galanes, the Senior Director of Business Development with Avangrid, to discuss their proposed project, the Excelsior Hub. I'll turn it over to Fernando and Sebastian, please.
Thank you, Greg. Hi, everyone. And well, first of all, thank you so much, NYSERDA, for having us today. Thanks, everyone, for your interest. As we know, we're definitely interested when it comes to transmission development and renewable development in the U.S. It's a great opportunity to be here to exchange your thoughts and have some debates on offshore transmission, which is a very healthy process. So please, next slide. Just quickly introduce myself. So as Greg said, my name is Sebastian Libatati. I'm VP of Business Development at Avangrid Networks. As you may know, we own 8 electric and gas utilities in the Northeast, NYSEG and RG&E, particularly in New York, serving 1.3 million customers. We're also part of the New York Transco, that's currently development for transmission projects in New York. We're also currently building the Nec Chvdc Project that received a very positive court decision a few weeks back, and hopefully we can resume construction within the next months. As you know, this is a project done by Avangrid on the US side and by Hydro-Quebec for both transmission and generation on the Quebec side, serving Massachusetts EDCs for 9.45 terawatt-hours a year for 20 years. We also submitted back last year during the Tier 4 RFP process run by NYSERDA, the Excelsior Connect, which is 108 miles of HVDC fully underground from upstate to downstate. And I'll just take here the opportunity to congratulate first NYSERDA on the entire process, but also on both CHP and Clean Path for being awarded. And although they're in very different stages of development, we definitely wish the best to our transmission developer colleagues. As you know as well, we're part of Avangrid and the Iberdrola Group. On the Avangrid side, our affiliate Avangrid Renewables is currently building the first commercial scale offshore wind project, which is Vineyard Wind 1, but also actively developing Park City Wind and Commonwealth of the coast of Massachusetts. And something very topical for this this particular webinar, which is sort of what the image is trying to represent here, is the work that's been done in the project that's been commissioned called the Western Link HVDC back in 2018 in partnership with National Grid in the UK. So this was accomplished by both Scottish Power and National Grid, and was at the time the longest HVDC submarine cable. Next slide, please. So what I'm trying to present here today is, quickly on two different slides, is the current state of the market and how we've, developed in the last few years our offshore wind industry, and then later on a few thoughts, solutions, proposed solutions at least we'd like to debate on this webinar. Well, first of all, as you know, the generator lead line is the model that was preferred right from the beginning. It was the case in the UK and different European countries, and is the one that we've used here in the US. A model that obviously allows for quicker execution, control of your own destiny. As we say, the generator with most experience is optimizing most of the time their overall cost effectiveness, right? Which means when it comes to transmission, they're trying to optimize distance, curtailment, and network upgrades, right? I don't think we've asked in previous RFPs for the generators to optimally develop the network, right? Which is completely fine, but it does trigger a set of consequences that we'd like to talk about today. Also, what we see both in New England and New York more recently is that we have now multiple awarded projects that are now shopping for the same real estate in critical areas in both New York, Long Island, and New England, and fighting over the same interconnection points, right? Which creates a lot of stress, delays, and so on. In some instances in New England, developers have found, collaborative ways to work together in developing these projects. And but particularly in New York, which is part of the topic today, we see a lot of challenges moving forward. When we talk about generators being in control of their destiny, with literally means is control of your capex, control of your schedule, control of your entire project, your contractors, and everything else that comes with it, right? Now we're asking, is this the right recipe, right? Maybe it is for the first few projects, but we've already seen a lot of delays, stress put on the projects, and also on the onshore network, right? So I think we need to ask these questions to ourselves: is this the right recipe moving forward? It definitely leads to lower costs in the short term. We've seen it in different reports, and we've seen it in simply the prices that have been submitted that have been very competitive. Also, the RFP processes that we've seen in Massachusetts and in New England states and in New York are definitely simpler when we simply ask for these offshore wind developers to submit an entire both assets, both the transmission, the generation assets, as opposed to running different RFPs in parallel, which creates some some challenges when it comes to coordination, contract structures, and risks. Also, the effect of this generator lead line is, as you can see, the interconnection queue in New York, for instance, is filled with potential projects, some that have been awarded, some that are in late stage of development, and some that are still just a simple PowerPoint. And what we've seen in the last few weeks with different announcements for coming from Equinor and CHP and CleanPath, I think we can all agree we're all fighting for the same interconnection points, right? Also, just before I finish with this slide, is we obviously all waiting for the outcome of the Long Island PPTN. New York ISO has been doing a great job so far evaluating the different proposals. It's highly complex. We're interconnecting in multiple TOs, but we're hopeful that by the end of this year or early Q1 2023, we'll see an outcome. So what this creates really is, or results in project delays, which creates by themselves cost overruns on the projects, higher curtailments, but also reflects on the entire project. It reflects into higher risk premium, which translates into higher dollars per megawatt hour that our ratepayers have to pay for, right? So next slide, please. So here, really, what we're trying to discuss with you all is what are the different solutions. We don't have a specific blueprint here, but but I believe it's the responsibility of our own industry to quickly move to a proposed plan, a more centralized plan that will help solve some of the current issues we see with the first few offshore wind projects. So question is, how can we quickly adapt and propose these implementable solutions? So before answering that question, I think we need to ask ourselves, what is the right risk allocation among the different parties that are involved in this industry? Can we ask, or should we ask offshore wind developers to be responsible and coordinate the build out of the onshore network? I believe the answer is no. I don't think that's their core competency, and I don't think they're in the best position to perform that. Can we also ask our transmission developers in the US to be responsible and build offshore transmission lines and substations and platforms with converter station, state-of-the-art DC converter stations? Does that align with their core competency? We're not saying they should not be part of it. We're just asking the question, what is the right risk allocation so that ultimately it leads to more competitive prices and more feasible projects? So now, one of the proposed solutions is, and I think we all agree here, which is, and I think this is a step in the right direction, and the reason why we're having this webinar is centralized planning. What are the benefits? How can we as an industry, along with New York ISO and NYSERDA, think about the medium and long-term solutions? If we can get anything out of this process in PJM in New Jersey, is that there's definitely a lot of innovation in price pressure on transmission development when we are competing against each other for whether it's offshore or onshore transmission. So not only centralized planning is necessary, but we believe essentially in competition for both assets. But here specifically, competition in the onshore transmission space that would definitely lead to more innovative solutions. Also, as a result of this, an holistic approach would definitely result in less marine and coastal impact and on our environment. We've seen a few reports dated back in 2020 by the Brattle Group. I think it was great work showing the numbers of cables laid that had to be laid from these BOEM lease areas to Long Island, Queens, Brooklyn, Staten Island. This is not feasible. We're not taking the right steps and we're not thinking long-term right now. We're thinking short-term. And short-term, as I said before, is not resulting in, or at least it's resulting in project delays and cost increases, which we want to avoid. So the solutions we're proposing today and would like to debate and hear you from is really will result in reduced risk premiums. It will definitely increase network benefits, more reliability and redundancy by centralized planning. It will definitely lower curtailments. Curtailments are a key aspect of the settlement and the PPAs that our offshore wind developers are signing today. And as you know, if you've been in a trading floor, how much it can affect your business case given the volatility between zonal and nodal prices in our network today. All of this cannot be accomplished without recognizing the value of bringing our stakeholders with us right from the beginning. There's no way we're building all these transmission and offshore wind infrastructure without having our key stakeholders and coastal communities being part of the solution. And it goes back, and this should be a simple circle. It goes back to centralized planning. If you have a centralized planning, you will consider all the constraints, environmental and social constraints, as well as technical constraints. I think we have the recipe for success. We just need to put that in a blueprint as quickly as possible because our industry really needs it. So I'll turn to Fernando Gallinas, And next slide, please. And thank you very much, everybody, for having us here.
Well, thank you, Sebastian. So following up on the presentation from Sebastian, Avangrid is developing different alternatives for the interconnection of offshore wind, all of them from scratch. We've put together a strong team with internal resources and external contractors in order to bring, all different expertises on board to capture different requirements, opportunities, and constraints. We've started with the, overall environmental impact of the different potential solutions and the optimization of the system and the interconnection viability, kind of focusing on the idea of having both ends of the transmission solution defined, evaluating the proximity to load, optimizing the transmission solution, and then evaluating the optimal deliverability, reducing energy curtailment, and obviously focusing on the optimized use of capital. Obviously, getting the best of the technology is also one of our targets. A lot has been said about HVDC solutions, and definitely those will bring a lot of value to the system. Next slide, please. We started by defining environmental and community constraints, working with our external consultants. We tried to understand the environmental and social impacts of the project. We did not consider the offshore component, only the onshore. We tried to identify optimal landing locations for our projects. And by building in environmental impacts, the use of land, the cultural resources, we created a heat map of the whole coastal area for New York City, coastal and obviously the Hudson River. And by weighting in different factors, we've been able to identify and categorize the different landing spots for the offshore cables. Again, the tool doesn't build in the routing complexity offshore, things like routing under the narrows. It's just considering the different factors onshore. Okay. As you can see on the screen, and that's kind of the summary of our tool. Staten Island and the Lower Bay are probably the best locations, only from the landing, from the environmental perspective. We did try to include some of our outreach findings in the project also to consider, some of these aspects once you get onshore. And obviously, these are not the best locations from the grid perspective, but definitely they are from the offshore developer perspective. Next slide, please. Once we identified, where the potential locations for the landing of the cables could be, actually at the same time, we tried to identify what would be the best point of interconnections. We have performed detailed interconnection analysis based on capacity resources for the different substations in New York City. Keep in mind that Avangrid participated on the Tier 4 solicitation, which gave us a good perspective of the system at the time as well. And from there, we moved into evaluating all the different interconnection points from the offshore perspective. The available capacity, and I think we all know this, is limited. It doesn't allow for direct ties for the full capacity of most of the wind farms without triggering major system upgrades. The grid in New York City, in order to take all the wind capacity, all the offshore wind capacity, will require significant system upgrades, which cost will be obviously transferred to ratepayers. One of the things that we identify is that by introducing a plan approach, this cost could be reduced and optimized. Also impacting the developer risk, as Sebastian mentioned, system congestion, and lowering the overall cost of the interconnection. Again, highlighting that although something could be done in order to improve the grid in the Lower Bay, Staten Island is clearly lacking the infrastructure for large amounts of energy to be interconnected. As you can see on the screen, this high-level summary of our findings from the transmission planning perspective or the integration perspective. for the different substations, right? For the screening of the interconnection points. Next slide, please. We've mentioned the plan approach, and I think it's a good idea to highlight what we mean by this, right? As we mentioned before, the overall cost of the offshore wind integration is going to be borne by ratepayers. It doesn't matter if it comes through the generation tariffs or the distribution tariffs, but one way or the other, the whole cost is going to be transferred. Planning ahead for these expenses, making the best use of the capital resources, will definitely bring more benefits overall, both for the system and ratepayers, than actually, putting all the pressure of identifying these upgrades to the offshore wind developers. The expansion of the existing facilities, the improvement of the system reliability, the clarity for developers on the grid conditions will definitely lower the risk of the development and eventually have an impact on the reduced cost of energy. If we target the optimized injection and the reduced congestion, will definitely provide a lot of benefits, a lot of visibility for offshore wind developers. We believe this approach will, if done holistically, could definitely allow for the achievement of the CLCPA goals, for the more aggressive goals that have been announced by the Commission lately, and will definitely also facilitate the best use of the offshore lease areas. We also believe that the opportunity of opening this plan approach for competition will allow to obviously bring the best ideas on the table, the best cost, and also give the opportunity to stakeholders to provide feedback and speak up on what the different constraints could be. Next slide, please. Based on this, there's a little introduction to what Avangrid has been developing. Again, we've brought in experts from not only engineering side, but also transmission planning, real estate, legal, permitting. We've done a quite comprehensive approach. We believe that by injecting and creating a landing spot, a landing facility south of Brooklyn, we could allow developers to bring in offshore wind at a competitive price, and then expanding the 138, 345 kV systems in the city, and potentially also creating secondary hubs that will allow for the offshore energy to move around the system in New York City and Long Island. We believe that these facilities will be designed to be expandable in the future. We believe that it will be also supporting the reliability of the system if properly designed, and will definitely improve the energy deliverability without impacting the energy prices. It's a great opportunity to improve the grid in the city, great opportunity to build new substations that are much needed, and definitely work along with the incumbent utilities to make this happen. We have developed completely two alternative solutions. One of them is holistic, as we see on the screen, trying to bring in all these benefits. A secondary one is more focused on the requirements of the current solicitations from NYSERDA, optimizing the developer approach. And finally, next slide, please. Summarizing the ideas that were said by Sebastian and through the rest of the presentation, and we believe the plan approach to offshore wind will make the best use of the infrastructure. I mean, several HVDC projects could be developed to integrate offshore wind. DC converter stations are highly valuable assets, and the best use of those converter stations will be they spread across the system. The idea of introducing several hubs will optimize the benefits of the offshore mesh and definitely reduce the basis risk for developers. This could be cost competitive versus the Gen-tie approach. It's just a matter of how system upgrades are designed, and could reduce future system congestion. Obviously, we try to sponsor a holistic approach where the offshore wind facilities will be considered. We'll try to avoid constrained routes, minimize the environmental and social impact, make the best use of the capital, and definitely start with solid interconnection studies that will provide visibility for future needs and also for the future conditions of the grid. And finally, as we are seeing on the success of the New York ISO and the sponsorship of the Commission on the competitive solutions for New York, open solicitations bring ideas from different transmission developers, innovative ideas, and allows different stakeholders to evaluate them and choose the optimal alternative. There's a successful track that proves this way in New York, and just following down that road could definitely help the development of offshore wind. And finally, just identifying clear goals and evaluation metrics is always positive for all transmission developers. And thank you so much, and thank you to the NYSERDA team for the organization of this webinar. Thank you.
Thank you, Fernando, and thank you, Sebastian. Much appreciated. We're now going to transition to a 15-minute Q&A that will be facilitated by Liz Grisaro, the Deputy Director of Electric, Gas, and Water from the Department of Public Service. And a reminder, if you have any questions, please submit them via the Q&A function at any time, and please direct them to all panelists. So I'm going to turn it over to Liz, and we'll cover a couple of questions that have come in.
Thank you, Greg. I think we might only have one question, and I'll ask Avangrid, if you could go back to your slides. The question that came in for you has to do with your slide number 10. So if you could pull that one back up, that would be great. And the question is on that, with respect to what's depicted on that slide. Did you assume existing substations or new substations in that graphic?
Yeah, thank you, Elizabeth. So we did consider existing substations. We did evaluate the available headroom available in each one of the existing substations in the 345 kV system and some of the lower voltages as well. So all of the ones that we see on the screen are the existing substations. Yeah.
This is existing. Okay, great. Thanks for that. Thanks for that clarification. Let me see if we have a follow-up from that. And it's a good question that I think we may come up again. Do you know or have you done a real estate study for the areas you show on slide 12 for potential substations and converter station sites?
I don't know if Sebastian wants to jump in.
I can start, Fernando. You can chime in, but yeah, definitely. If you see our smiles, is simply because we've walked the area multiple times, and we've basically scanned the entire not only area that we show here, but multiple other areas around New York City. One thing is, there is definitely space and real estate that can be optimized. Now, the question is, when it comes to execution, right? Do we have the right incentives now to take on these development risks in moving ahead with the purchase of multiple real estate locations in Brooklyn? The answer is no. But to your first question, definitely, we've done all the studies. We've identified multiple areas that have lots of potential and that are basically poorly used right now that could benefit from offshore wind development. But yeah, the next step is execution.
Okay, fair enough. Follow-up question. The next one is, where do you expect to locate a new substation, and how many offshore wind developers would be able to connect there? Do you have thoughts?
I can take this one, Sebastian. So our approach was to take at least 2,500 megawatts on each one of the solutions. So the real estate we've evaluated could hold up to 2 large converter stations, plus all the AC infrastructure required to integrate.
Okay, so this new substation could handle up to 2,500 megawatts. Is that what you said?
Yeah.
Did I get that right? Okay,
yeah.
Just to make sure I heard you. Okay. Let's see. We do have a couple of questions popping in. The next one is, how does this strategy concentrating, landfall in an area like South Brooklyn incorporate redundancy to compensate for concentration? And I'm not 100%. If you're clear on that question, please answer. If not, maybe Mike Carr, you could unmute to explain. Do you guys follow the question, or should we ask Mike?
I can try to follow up. I don't know if I will be answering the right question, but I can definitely try.
Okay, great.
We believe it's not a large concentration. It's only 2 projects what we are considering, basically, based on today's standards. That's definitely an amount of energy that could be handled in a single landing location. We didn't try to go further than the 2,500 megawatts, just because it will definitely be a large concentration of power in a single location. Yeah. So we kind of agree on what the question is, but we believe 2,500 is quite reasonable. Yeah.
Okay, that makes sense. Mr. Carr, did that answer your question sufficiently?
Yeah, participants can't unmute, Liz.
Oh, they can't unmute. Okay, well, if you could give us a thumbs up or something, that'd be great. Follow-up, next question. Did you perform any short circuit power flow stability assessment or physical feasibility assessments for this proposal?
Okay, that's going to test my technical knowledge, but definitely we did. We did evaluate it. We even consider N-1, N-1, constraints in the city. Obviously, we know that's complicated, especially the N-1, but we didn't get as far as the stability analysis. That should be the next step once we define the final capacity of the interconnection point.
Okay. And we have some questions that are a bit more kind of about project execution. Do you have cost estimates? Have you developed cost estimates?
Yes, we have.
Okay, and
including
we cannot share them.
you're not. Okay, that was the next part of the question. Are you prepared to share them? So you've done cost estimates with relation to this 2,500 megawatt proposal.
And we believe those are quite accurate. We submitted the proposal on Tier 4 that require the same scope of work, quite similar at least to what is required for the interconnection of the offshore wind. So we have fresh estimates, if you let me say that, and we believe that our cost estimates for the solution are quite accurate. And by the way, we've been working with local contractors, local companies in New York City for these estimates. So it's been a bottom-up build-up of the cost estimate. It's not just pure desktop analysis. Yeah. Okay.
So here are a couple of questions that are, related to the same topic. So I'll try to summarize. Why are you proposing to land in South Brooklyn rather than going through the Narrows and Upper New York Bay?
And to be honest, we have a solution that goes through the Narrows as well. That's what we mentioned when we say that we have 2 alternatives. Our first approach was to make the best use of the Lower Bay because of the question being raised of the routing under the Narrows. We are all very well aware of that. It's going to be a limited number of cables that will go under. Finding a better alternative could definitely be a good solution for all stakeholders. That's why we approach from that perspective. There was another reason as well. Early in the process of developing the solution, we did consider some AC interconnections. If you consider the AC alternatives instead of DC, landing on the Lower Bay is even a better alternative.
Okay, thanks for that. I think we have a couple more similar questions. Hang on one sec. All right. Have you done anything to look at and evaluate feasibility of construction of putting subterranean cables through Brooklyn?
We have. We know it's challenging. It's not going to be simple. Disadvantaged communities were taken into consideration as well. So routing has been built in considering all different factors. We believe it should be feasible, but it's going to be challenging. It's going to require inputs from different stakeholders, and it's going to be a process that we need to follow.
We've also worked closely in the past 14, 18 months with existing contractors in New York City that are building on a consistent basis underground cables, and brought in other expert contractors to understand the permitting side of it. And, but as Fernando pointed out, ultimately it comes down also to the community plan and outreach to route these underground lines and into the right places.
Okay. Similarly, we have a questioner asking what marine surveys you've done related to the proposed landing sites and other alternatives you've looked at?
Yeah, just keep in mind that we are acting as a transmission developer. We focus our development on the dry portion of the project, so only from the landing spot onshore. We have not performed other than some basic analysis on existing routes, existing right-of-ways, and obviously the routing under the narrows.
Okay.
Those being the only things that we consider.
Okay. Now, and I want to make sure I understood you. I think you said you had two proposals, right?
We do. The one that we've seen in the screen and a second one that goes
And a
under the
second.
narrows. Yeah.
Okay. So how do your proposals interact with the proposed Con Edison clean energy hub?
So these solutions have been developed, as Sebastian mentioned, over the last 18 months, 24 months. At the time of starting these ideas, these solutions, we did not have enough information on the Brooklyn hub from Con Edison. So we are not considering that alternative at this point. Yeah.
Okay. Technical question: how many feeders would need to be connected to your hub? Would be needed to connect your hub to the rest of the system? Did you look at that?
That's a great question. We've looked at different alternatives. I don't want to enter in too many details because of the confidentiality, but the number ranges from 2 to 6, depending on the solution and the location. Okay.
Let's see. Are you in the NYSO interconnection process for
no, we are not.
either or both of these? I'm sorry, what did you say?
No, we are not. We don't see the need to be in the interconnection process at this point. Okay. I mean, yeah.
Okay. Do you have an in-service date in mind as you've been working on this?
We have a schedule for the execution of the project, but we need to build that schedule into the developer's global schedule for the offshore wind. We don't think we are going to be the main constraint on the development. That's the approach.
But you can't give us. But you can't give us a sense of what your hoped for or targeted in service might be.
Again, I mean, we have an internal estimate.
Yeah, I think what Fernando is trying to say, there are multiple variables here, and it ultimately depends on the technology, the right size in cables, and coordinating with offshore wind developers. So I don't think based on recent RFPs and supply chain constraints, if we're going full DC with our solutions, I don't think it's realistic to say that we could be in service before 2026, 2027. We've been developing HVDC projects in the past, and from initial design to commissioning, we're talking about at least 44 to above 50 months easily.
Okay, thanks for that. So is this a proposed project, or do you have any permits related to it at this point? Either of them?
We do not have any permits at this point kicked off. Yeah, we think it's going to be so the permitting of the project is going to be part of the full permitting of the offshore wind project. So we need to be coordinated, especially on the outreach side, with the offshore wind developer.
That's an interesting point. I have a question that I think relates to only one of your proposals, and that is where does the proposal to go through the Narrows land in Zone J?
Yeah,
Go ahead.
it's definitely, as you've seen in Fernando's slides, we did not show a precise landfall for the second solution, simply because there's an ongoing RFP, and we want to keep that confidential.
Okay. Let's see. And another one. We had an indication from Con Ed at the earlier session that they estimated the cost of running cables in New York City at 50 million per mile by land and 20 million a mile for underwater. Are those estimates consistent with or in line with what you're seeing for your projects?
So let me answer differently. Reading through the WSP document that was presented, I believe, last week, we are closer to the estimates on that document than to the estimates from Con Edison. And that information is public. I mean, the report has been made public.
Right.
Yep.
Okay, got it. I think that seems to be it for questions from our participants. I think there may be a question from one or more of the state agency folks. Dave Kaup, did you have a question?
Can I actually unmute?
No, I can hear you.
Oh, great. On your map, I don't know if you can put it back up, that showed the hub and then a couple of white arrows going north and
Yeah, that's slide number, let's see.
13, I believe.
You roll back a few slides, please, Sal.
Yeah, that one. 12.
okay. It's just hard to make out what's on this slide. At the end of the arrow, is that on this almost directly north? Where's that ending?
You mean the arrow that goes to Gowanus?
Is that where
Gowanus?
it's supposed to go to?
Yeah.
Gowanus?
Yeah.
Okay. Thank you.
Okay, good. Couple of people in the Q&A have been reacting to what you said a moment ago about the WSP report and are asking what that is or what that was. Greg Lampman, do you want to tell everybody what document it was that the Avangrid team was referring to?
Yeah, we need to wrap up the Q&A as well, Liz, but
Yep.
the document being referred to, NYSERDA currently has an RFI on the street for feedback on an offshore wind cables assessment. You can find that on NYSERDA's funding opportunities page. It is basically a work to try to understand what constrains offshore wind cables from getting to their points of interconnection and where those constraints are. It's a joint effort by NYSERDA and the state agencies to try to develop that and synthesize the information in a way that can be consumable by developers and others. We're looking for public feedback on that via that RFI. So please stop by the NYSERDA RFP page or our funding opportunities page, and you can access the report there as well as the questions that we're asking via the RFI itself. But again, it's an assessment of what constrains offshore wind cables from getting to their points of interconnection and where those constraints are. So thank you very much, Liz, and thank you very much to the Avangrid team.
Good, thank you.
Thank you.
Can I get the next slides, please, Sal? So next up, we have a presentation from Frank DeSimia, who's the Director of Business Development with the New York Power Authority, and he's going to be presenting with the team, speaking about the Richmond Spoke and the King Spokes project. I will turn it over to Frank.
Thank you, Greg. Can I get a sound check?
You sound great.
Great, thank you. Good afternoon, everyone. I'm Frank DeSimia, Senior Director of Development at New York Power Authority, and on behalf of the teams that work tirelessly on developing these projects, I will be presenting on 2 offshore wind interconnection solutions. Each of these solutions will be presented with a high-level overview today for public disclosure. Girish Bahal from NYPA, along with Lawrence Willick from Ellis Power, will join me later during the Q&A session to further discuss questions that may arise. Next slide. The first interconnection solution that we will discuss is a joint collaboration between NYPA and Ellis Power that we've named Kingspoke. Kingspoke is a turnkey solution to offshore wind developers that will provide low-cost and low-risk interconnection opportunities into New York City by minimizing scope of facilities, including system upgrade facilities, reinforcement of the existing bulk transmission system, providing reliability benefits, and avoiding the physical constraints of New York Harbor and the Narrows. Kingspoke is a collaboration between NYPA and Ellis Power, who have experience jointly collaborating on development, siting, construction, and operation of bulk transmission assets, namely the Central East Interconnect project currently ongoing in the Capital Region. Additionally, both NYPA and Ellis Power submitted proposals independent of each other and are in consideration for the Long Island offshore wind export public policy transmission need, where each individual entity performed extensive transmission planning studies and modeling that took place evaluating the effects of injecting between 9 and 12 gigawatts of offshore wind into the NYPA, the New York control area, with injections in both New York City and Long Island. Next slide, please. The Kingspoke project was born through innovation to offset the existing challenges with interconnecting offshore wind in the southeast New York. These challenges and constraints comprise of availability of points of interconnection that can accept the full injection of offshore wind, physical constraints outlined by New York Harbor and the Narrows, availability and cost of real estate to house transmission infrastructure, namely the high voltage DC converter stations that require between 3 and 5 acres per converter station, and the risks of system upgrade facilities being identified within the NYSO interconnection process. I think that Fernando and Sebastian touched upon many of these challenges in the previous slide, as will many others during today's process and during many of the conferences that have taken place, mainly about interconnecting offshore wind into New York City over the past few years. Next slide. Kingspoke is creatively designed to solve many of the issues that were just identified by providing offshore wind developers a full turnkey 1.3 gigawatt plus solution that includes a cable landing location, a routing and siting studies, an HVDC converter site, and a point of interconnection substation that would be designed with the site and the real estate attached. We believe that this is a flexible injection. While we're currently working on a 1.3 gigawatt solution, Kingspoke is anticipated to be flexible and could potentially be accepting 2.5 gigawatts plus upon completion of further transmission planning studies. Off to the left, you can see a graphic of the proposal for Kingspoke. Kingspoke plans to inject into Brooklyn, Kings County, come on shore. We anticipate that there will be a point of injection substation that we're calling the Kingspoke Substation in East Flatbush that would then, through spokes, connect to various points on the existing bulk transmission system, connected to the 2 back ends of 2 radial feed 138 kV transmission pathways in Brooklyn. Next slide. Avangrid and Greg just talked a little bit about the draft offshore wind cable corridor constraints assessment that NYSERDA released recently. For our cable landing in Far Rockaway, we found that that's a significant benefit of the Kingspoke project, as it provides optimization and additionality of interconnecting offshore wind through a different location other than New York Harbor and the Narrows. While the team has been studying this landing, NYSERDA's recently released assessment found that this cable landing is viable and achievable. And while no cable pathways or landings in Southeast New York are without individual challenges or constraints, some have less risk than others. Far Rockaway is opportunistic and would require mitigating the following challenging but not insurmountable constraints. There is a popular beach and fishing area. There is a Williams Transco 26-inch gas main. The Neptune HVDC transmission circuit crosses through that area. There is a 400-plus acre artificial reef, and there is an Army Corps borrow area adjacent to the 400-plus acre artificial reef. Next slide. As we just covered the cable landing, our current status for the terrestrial portion of Kings Spoke is the following. Routing studies and the associated cost estimates are completed. The sites for the cable landing, HVDC converter station, and Kings Spoke substation have been identified with negotiations underway. The initial transmission planning studies identifying injection capabilities of 1.3 gigawatts were completed, and an interconnect request under queue position 1435 has been reserved and filed. The Kings Spoke point of injection substation has preliminary design and run lines, and coordination of interconnection of existing circuits, routes, and cost estimates, along with the NYSERDA interconnect process, continue to advance. Next slide. If any developer wishes to collaborate on Kings Spoke or obtain further information, please feel free to contact myself, Frank DeFemia, or Lawrence Willick at the below email addresses. NYPA will now provide an overview of a second offshore wind injection alternative that we call Richmond Spoke. Next slide, please. Next slide. Richmond Spoke is a standalone NYPA project that involves the injection of offshore wind on Staten Island in a hub and spoke model. Since NYPA and Ellis Power, along with Avangrid, spoke at a high level earlier about studying and proposing offshore wind interconnection alternatives, we're going to jump directly to the project overview and status. NYPA has performed transmission planning studies identifying injection capabilities of a full offshore wind project at 1.3 gigawatts with expandability up to 2.5 gigawatts. An interconnect request under queue position 1308 has been filed and is currently in the interconnection process with the NYSERDA and the interconnecting TO Con Edison. The project aims to leverage the strengths of Staten Island to interconnect offshore wind, including strategic benefits of being located parallel to the Narrows constraint and the availability of real estate to site bulk transmission assets. Once sited, it is envisioned that local offshore wind injection, along with system reinforcements via additionality, hence the spoke portion of the hub and spoke model, will provide additional system benefit, resiliency, and redundancy to the bulk transmission system. Next slide. Our current status for Richmond Spoke includes ongoing efforts on routing studies and associated cost estimates, identification and site control of the cable landing, high voltage DC converter station, and Richmond Spoke POI substation. We have preliminary one-line diagrams and substation designs that will follow the site control. And we continue to coordinate on interconnection activities, routes, cost estimates, and are refining and pivoting as things change along the process. Next slide. If any developer wishes to collaborate on Richmond Spoke or obtain further information, please feel free to contact myself, Frank DeFemia, and/or Garish Bahal at the email addresses below. On behalf of the NYPA and Ellis Power development teams, we'd like to thank NYSERDA, DPS, and the webinar attendees today for participating and providing us with the forum to discuss Kings Spoke and Richmond Spoke. I'll now hand it over to Liz Grizzaro to kick off the Q&A session.
Great, thank you, Frank. And thanks for being succinct. Let's go to the questions. We have a few. Let's see. One questioner, and after listening to you, asks whether studies have considered the pending NOx shutdown of up to 2,500 megawatts of GTs connected to the Con Edison 138 kV system, including the 3 most recent Con Edison upgrades from the 345 to 138 kV system. That's kind of a complex question, but can you tackle that one?
All of our transmission planning studies consider the most up-to-date information available. I will say that in studying for Richmond Spoke, the GTs, the gas turbines connected to the 138 Con Edison system were studied, and we looked at system impacts and benefits of whether or not retirements of those assets were to occur in line with the CLCPA targets for the NOx rules.
Okay, thanks for that. Looking at the Richmond project, do you have a landing point on Staten Island?
We currently have evaluated a minimum of 5 landing points, and we are actively in discussions with more than one entity who has site control of these, let's say, 5 locations.
Right.
And we are pivoting as we discuss site containment and acquisition with those landowners.
Just a reminder, somebody might have missed the megawatt capacity for Kings Spoke. Can you just remind us? I think that was on your slide. Was it 1.3 gigawatts?
So both Kings Spoke and Richmond Spoke are envisioned to be adaptable and expandable. So the initial projects for both have been studied at 1.3 gigawatts with expandability in mind for both of those projects, including the site acquisitions.
Great, okay, thank you. But I remember the 1.3 figure from your slide. Let's see, have you actually identified the assets and the upgrades, such as new transmission feeders, that would be required for these 2 projects?
Yes. So our transmission planning studies have identified how to interconnect into the existing bulk transmission system. The nice aspect of hub and spoke models is that they are adaptable, and that depending on the overall configuration of the POI substation, there is the ability to continue adding resiliency and redundancy through new spokes. And we continue to align, refine, and pivot based on the injection capabilities. So the smaller 1.3 gigawatt project, the substation would be built with future use in mind and may only have spokes that connect to the system to enable the deliverability of the initial 1.3 with future capabilities in mind for future spokes to enable the deliverability of the future projects.
I'm going to ask a question for myself here. What's the outer envelope that you're thinking about in terms of expandability?
Right now, we're looking at 2.5 gigawatts. So initially, it's one full 1.3 gigawatt project,
okay.
And the second expansion would be a second 1.3 gigawatt project, so 2.6.
Okay. Thank you for that. Okay. One of our questioners asks, what shore of Staten Island are you evaluating for the landing points?
I think many people have identified that there are significant constraints in entering the Arthur Kill. So much of our evaluation has been on the South Shore and the Eastern Shore of Staten Island.
Okay, south and eastern, makes sense. Any marine surveys done with relation to either of these project proposals?
So both Richmond and King Spoke are envisioned to be terrestrial-based transmission projects, partnered and coupled with the offshore wind developer bringing their HVDC cable onshore. So both Richmond and King Spoke envision providing a cable landing location and taking execution and development opportunity from the cable landing to the point of interconnection on the bulk transmission system.
Okay, so you see that that being an aspect of the offshore developers study work.
And Liz,
Yeah.
you know, any future spokes, right, new transmission circuits that would be required to connect back to the bulk transmission system would have the appropriate level of diligence from marine surveys and other system impacts studied appropriately.
Right, okay. Let's see. Have you found, and are you taking account, do you have room available for your converter stations? Is that one of the things you're working on when you talk about looking at site control and land issues?
So we look at both projects, Richmond Spoke and King Spoke, as being full turnkey solutions.
Right.
So what we're looking to do is we're looking to provide a cable landing location with an easement, provide offshore wind developers with site containment on the high voltage DC converter station location, and also provide site control for the point of interconnection on the high voltage AC side. And as I mentioned before, site control has been identified and has been pretty far along for the King Spoke project, and we're still refining our search on Staten Island as part of Richmond Spoke.
Yeah, I got that impression that King Spoke was perhaps a bit further along in that aspect. Is that fair?
Yes.
Yeah, okay. Again, looking at the Richmond proposal, getting power out of the island is a major constraint. One questioner asks, have you identified the additional or any additional transmission reinforcements needed to enable flows to the city? And did you assess those for cost and feasibility?
That's actually a great question. As part of our routing studies, we are identifying and very strategically looking at the cost of interconnecting new transmission feeders to and from Staten Island. And we're also looking not only at the cost of doing so, but the system benefit and reinforcements that go into pursuing those strategic investments. So that is well underway, but we're not here today to talk about cost associated with the spokes at this time.
Okay. I'm gonna move around here a little bit. Would either Richmond Spoke or King Spoke be paired with fossil generation retirement?
That's actually a great question. And I'm assuming that has to do with the NYSERDA OREC RFP, considering the stipulations in that RFP. I'm not going to give a firm answer there. What I will say is that right now we look at these as being standalone projects, but there is always additionality on all of these types of projects to package with the retirement of fossil generation, installation of energy storage, and or potentially hydrogen.
Okay. We have a couple of questions that kind of go to your intended, commercial structures. And I realize you may not be able to answer those fully, but let's try. What sort of commercial arrangement are you proposing to have with an offshore wind leaseholder?
So Frank, you want me to jump in?
I was going to prompt Garish or Lawrence if they wanted to jump in on this
Okay.
one.
I think Liz and the listeners, this is Girish Bahal from New York Power Authority. We are pretty flexible with respect to our structures. So, if you have an interest, feel free to give us a call and we can have that discussion in detail.
All right, then. I think you gave out your phone number.
That works too.
So, okay. Focusing on, sort of your own roles, what's your intended ownership model? Would it be something like NYPA building, owning, and operating the new, call it the hub, and the spokes to existing Con Ed facilities? What's your plan there?
There is definitely a lot of flexibility we have with respect to the ownership model itself. As folks may know, we have done at NYPA quite a few innovative ownership structures over the last 3 or 4 major projects we have developed. So we are open to any and all structures that create a win-win situation for the project, because ultimately for us, the goal is to enable integration of offshore wind into the New York grid.
Girish, this is really a question coming from me, not from the participants. I dimly recall there are some restrictions on NYPA's ability to enter into certain kinds of co-ownership arrangements. Am I remembering that correctly?
There are restrictions against equity ownerships, but there are no restrictions against asset ownerships. I
see. Okay. Would you envision the developer building and owning the onshore HVDC converter station? Is that a possibility in your model?
Yes, it is, and it actually makes sense for the HVDC conversion onshore and offshore to be coordinated, because they tend to be of the same design, and controls need to be very similar.
Right. Okay. Have you engaged the Article 7 permitting process yet for either?
We have not started the Article 7 permitting process yet. Once we finalize our real estate ownership structure, we will be starting that process. But again, going back to what Frank presented, we have done very extensive route analysis and route studies. They have been completed. So, from our perspective, once we have certain locations finalized, it's a lot easier to file an Article 7 at that point.
One other, I think, clarification from one of our listeners. Is the LS Power team partnered with NYPA for both of these projects, or just for King Spoke?
Just for King Spoke.
Okay.
Yeah.
Yeah.
Hey, Liz, if I can jump in, Lawrence Willick with LS Power. I just want to clarify, because we've been using LS Power, which is, a larger organization, and we're the LS Power grid transmission part of the business, separate and distinct. I think later we'll be hearing from Rise Light and Power, that's also an LS Power company, and we're, 2 entirely different sister companies that have different activities and different teams. So,
thanks.
The LS Power grid that's partnered on just the King Spoke project.
Okay, thanks for that clarification. We did have someone who was unsure. Let's see. Any other permitting related questions? Okay, have you looked at or thought about permitting requirements to get cable to Richmond?
So Liz, this is Frank DeFemia taking over for Garish Ball on this.
Yeah.
The NYPA team is actively engaged in the Article 7 permitting process for multiple projects. We're actively experienced developers and transmission owners and have recently acquired multiple recent Article 7s, including one last month for Smart Path Connect. And we will be actually filing an Article 7 in the upcoming month as part of the Clean Path New York project that has very similar cable entry and exits into New York City. So we are experienced in that entire process.
Okay. NYPA folks, maybe this is for Garish, do potential partners have to be pre-qualified through some competitive process to work with you?
I would say it depends. The AREC CBA process gives a certain amount of flexibility when we are working on large-scale transmission projects in terms of what we do and how we connect. So I think it's very important for us to also point out that these two projects, both Kings Spoke and Richmond Spoke, have been filed as TIP with NYSO. So from that perspective, they are, part of the NYSO tariff structure. And as far as NYPA is concerned, pre-qualification of competitive partnership really will depend upon the interest that is demonstrated and in terms of, how folks would like to propose projects into NYSERDA OREC 3 RFP.
We have time for one more, and then we'll move on to the next presenters, please.
Yeah, I'd like to kind of pull from our prior discussion and ask, the NYPA and LS Power Grid folks, what are your, anticipated in-service target dates?
We plan to package both projects as part of the NYSERDA OREC RFP. So in order to ensure deliverability and in service of the offshore wind projects, we would plan to work with the offshore wind developer to ensure that the AC aspects of the project to the point of interconnection would be completed prior or with the generation components of the project. So let's say 2028, 2029, 2030, depending on the schedule of the project as proposed in the NYSERDA OREC RFP.
Got it. Okay. And when you say, you mean the one that's currently open?
Yes.
Okay, very good. Yeah, I think that wraps it up. Unless, Greg, there are any questions from the staff side?
Nope, I think we're all set, Liz. Thank you.
Very good. Okay.
Thank you very much, Frank, and the whole NYPA team. Appreciate it for a very informative presentation. Get the next slide, please, Sal. Next, I'd like to welcome the RISE Light and Power Group, beginning with Clint Plummer, the CEO, but also he'll be presenting also with Rebecca Zwier, who's the Vice President of Environment Management, and Jamal Khan, who's the Project Director, and they'll be talking about two projects, the Renewable Ravenswood and the Queensborough Express. I'll turn it over to the RISE team. Welcome.
Hey, Greg, thanks so much. And let me say thank you to everyone who's dialed in today and to all of our co-presenters for bringing forward some very interesting concepts. Just a very little bit of background. RISE Light and Power is the owner of the largest generating station in New York City. It's the Ravenswood generating station, and we'll talk a little bit about that. But there's another angle to this, another bit of background, which is before I came here and became CEO, I spent 13 years in the offshore wind business. And the projects that we're bringing forward here today are really informed by having lived through some of those very challenging periods associated with making the first offshore wind projects in the United States actually happen. If you can go to the next slide, I want to just give a little bit of framing context around this, not the lawyerly disclaimer. Next slide, please. Every offshore wind project in the United States, with rare exception, has had extraordinarily challenging times with securing the rights necessary to bring the power to shore. Obviously, we all know the tortured history of the Cape Wind project. Obviously, we know that the Block Island Wind Farm ultimately made it through this, but a lot of people forget that Block Island was delayed for over a year as a result of a dispute over the cable landing. And it's not just limited to those New England locations. Obviously, I'm very proud of my role in New York's first offshore wind farm, the South Fork project, but that project itself suffered a non-material delay based on opposition to the onshore cable routing associated with it. And more broadly, beyond that, we see this coming up everywhere that offshore wind is proposed. Delaware had a project with a fully approved offtake agreement that ultimately died because the local community wouldn't provide it with its cable landing rights. And separate from that, we can see all the challenges that are coming forward in Ocean City, New Jersey right now associated with cable landings. The point that I want to leave folks with is this is not hypothetical. This is real life and death for offshore wind projects. And as the offshore wind developers listening in can surely appreciate, this has a material impact on your project's viability. It has an impact on your project's schedule. It has an impact on the various risks and costs that your project's going to have to live with. I sympathize. I've been there. I've lived with these challenges, and I've presented to the community boards that don't have nearly enough time to take up complicated issues like this and that end up potentially killing projects. And so when I came to RISE, a big part of our focus was on using the very unique set of assets that we control to be able to make life easier for offshore wind developers. Next slide, please. Now, it's worth bearing out just a little bit of context on what this organization is. So RISE owns two principal assets. One is the Ravenswood generating station in New York City. We're going to be spending most of our time today talking about that. It's New York's largest generating facility, 2,000 megawatts of operating capacity. And then separate from that, we own a comparably sized 26-acre site in New Jersey that we're also using for offshore wind development purposes in connection with New Jersey's SAA process. I'm not going to talk about that today, but just to frame what the organization is. Next slide, please. Let's talk a little bit about Ravenswood itself. Ravenswood is a 27-acre site. We own it in fee. The site viewed here, looking from Manhattan, from the west looking east, very southern end of our site, units 10 and 20. Center of the site is unit 30. Those three units are 1960s vintage Rankine cycle steam turbine generators with a cumulative nameplate capacity of about 1,800 megawatts. Unit 40 is a 2004 vintage combined cycle facility, one of the most efficient, newest in New York City. We also have a small Con Ed steam plant on our site. And then at the very northern end of our site, we have a 7-acre parcel that is formerly occupied by a fleet of 17 aeroderivative peakers from the 1960s and 1970s. Since LS Power acquired Ravenswood in 2017, we have undertaken a campaign to systematically retire those in compliance with various environmental regulations. We're now at the point where 16 out of 17 have been retired. The last one goes out of service in May of next year. That means that as of May of next year, we've got a 7-acre site that we own in fee that's abutting two of Con Ed's largest substations that is ready for development. And we've been focused on that development for the last several years since I've been in this job. Next slide, please. Now, looking at what we have today, Ravenswood is a critical energy infrastructure asset for New York City. We represent about 2,000 megawatts, the largest single generating facility in the city. We've got over 100 employees on site. The vast majority of those are union, represented by the Utility Workers Local 1-2. We've retired, as I mentioned, about 500 megawatts of peaking capacity. We're also very active in the local community. Our average annual local charitable giving budget is in excess of $500,000. I will note that we're also a critical part of keeping the lights on. Very recently, as those of you who are in New York City know, we've been through some heat waves this summer. Peak day so far this summer was on July 21st. At that point, we were producing all 2,000 megawatts of our capacity at full output. And for several hours, we were providing nearly 20% of all the energy used in New York City during that period of time. So it's big, it's an important asset, but it's also one that we recognize is going to need a transition over time. And so our strategy around the future of this site has been one of a set of renewable repowerings of these assets, principally anchored on HVDC transmission. Next slide. The fact that our site is so big and so old and has been so involved in this community for such a long period of time, we view as something very important to manage. Ravenswood was built in the 1960s, and it sits across the street from the largest single public housing development in the United States, the Queensborough houses, part of the New York City Housing Authority. Now, this is a part of New York City that has historically experienced some of the highest rates of respiratory illness in the entirety of New York State. And so we have, over the last several years, made a very concerted effort to build very substantive relationships around this facility. We're very proud of the results that we've received from that. We've talked with the community, we've listened to what matters to these folks. As you see in the picture below, we've worked on numerous occasions to open the gates and bring people in. And when you hear the stories that these people tell, it's quite heart-wrenching of people who have lived in these communities for such a long period of time and who haven't had anyone listening to them. I've heard people tell stories of having lived in this community their entire life and never been inside this facility, and having people literally crying, talking about how pleased they are with the vision of transforming New York City's largest fossil generating facility into this hub for clean energy. Next slide. So that's what we're doing. Several weeks ago, we publicly unveiled our plans for the future of the Ravenswood site. It's a comprehensive vision that we refer to as Renewable Ravenswood, a plan that will transform this largest of New York City's generating stations into a hub for renewable energy that we believe is replicable in other places as well. It's built on 4 simple principles. Number 1, bringing significant volumes of renewables down from upstate New York over a new HVDC transmission facility that will terminate at the Ravenswood site and will serve as a renewable repowering for one of our 1960s vintage steam turbine generators. Second, as folks know, we have for quite some time been developing large-scale battery energy storage on our site and have received a CCPN from the Public Service Commission for the first phase of that project. Third, topical here is our plans for the development of offshore wind, which I'll come back to. And then fourth and finally, this is an aside, we have a very unique ability to repurpose Ravenswood's once-through cooling infrastructure to be able to provide geothermal heating and cooling via a very large central plant that we're developing using water source heat pumps to provide zero emissions heating and cooling for the surrounding community, including potentially some of those NYCHA facilities that I made reference to. So this is Renewable Ravenswood. It's a plan through which we will retire and replace all 1,800 megawatts of our 1960s vintage fossil generation with renewables supplied from a combination of resources in upstate and offshore, delivered into our site over a set of HVDC transmission facilities. And in connection with that, developing these ancillaries, including the battery energy storage and the district thermal energy, as means of supplementing the benefits of our site for renewable energy purposes. Next slide. This plan has been informed through deep consultation with the local community. We've developed partnerships over the last several years with all the organizations you see here and with many, many others. And we've developed these plans by listening to what they've told us is important to their communities and things that will benefit their communities. We have a full-time staff of several folks who are just focused on building and cultivating these relationships, because we know that's important for not only continuing to operate this large fossil generating facility, but also critically for being able to affect its transformation into this hub for clean energy. Next slide, please. That also includes strong statements of support for this plan from local community leaders, from elected officials, from faith leaders, from our union leadership, and of course, from leaders within the environmental justice community. This is a plan that we've been working on in close concert with this community for many years, and that support that's developed from that is represented by these strong statements of public support from all of these leaders. Next slide, please. So that brings us back to the matter of hand, which is delivering offshore wind into New York City. This is a very hard thing to do. I've been at this for the last 15 years, and it's hard to get power into New York City. But Ravenswood provides a very unique aspect to this because we're waterfront, because we own the real estate, because we have the ability to physically connect into those substations, because we physically abut them, and because we have the existing capacity resource interconnection rights, the CRIS rights that allow us to inject. And because we think of these HVDC transmission facilities as the means by which we will prosecute a renewable repowering of the existing assets, we can make use of the NYSO's prior precedents for repowering to be able to do something very new. That brings us to the Queensborough Renewable Express, the project that we are advancing as a means of delivering offshore wind into New York City. This is a multi-line offshore transmission facility that anticipates being able to deliver up to 3.9 gigawatts of offshore wind. The reason that it's 3.9 gigawatts is that the NYSO has a single unit contingency of about 1.3 gigawatts per unit. And so our facility is designed around up to 3 particular units. That would be 3 separate sets of submarine cable, each in its own discrete trench, each one capable of operating completely independently. And each one of those critically paired with the retirement of and taking assignment of the CRIS rights from one of our 1960s vintage fossil generating units. Next slide, please. The overall architecture of Queensborough is quite simple. We anticipate that there will be an offshore converter station located in the OCS lease areas, set of submarine cable running in through the route that you see in light green on this map above, terminating in a new GIS AC substation located on the Ravenswood site, ultimately connecting into both of those new, existing converter stations, Rainy and Vernon, that abut our site. We are on schedule to be submitting our Article 7 application for this before the end of this year. We are planning on initially submitting the Article 7 around the first 2 circuits, with there being a potential for a third at some point in the future. Next slide, please. We've also put our money where our mouth is. And while we've been relatively quiet about this over the last several years publicly, we've been doing a tremendous amount of work behind the scenes. So in the last 2.5 years, we have completed over 250 miles worth of submarine surveys conforming to BOEM's GAGARC spec, accounting for geophysical, geotechnical, archaeological, and other environmental factors. and incorporating all facets of data collection necessary to fully design the route from the OCS into the Ravenswood site itself. Next slide. Based on that work, we have developed a comprehensive plan that accounts for all aspects of how we actually make the physical connection from the OCS into Ravenswood, accounting for environmental factors, accounting for archaeological factors, accounting for soil conditions and thermal resistivity, and what types of burial tools will be necessary, and critically, accounting for each and every single one of the infrastructure crossings that will be necessary to traverse from the OCS into the Ravenswood site. And the benefit of this is it's all in the water. We own the waterfront. We own the quayside itself. And so in between the OCS and the landfall on the property that we own, there's only water. And in that respect, we are dealing only with state and federal approvals for granting rights within that. We have undertaken the comprehensive surveys necessary to de-risk that in consultation with the maritime stakeholders and a variety of the agencies having jurisdiction here. And based on that actual physical work of gathering survey data and that actual work of consulting with all the stakeholders, agencies and otherwise, we have a very high confidence in this route being actually executable, particularly because there's no private or municipal real estate needed for this. We control everything that's not in the water. Next slide. The Ravenswood site also provides a great deal of flexibility in terms of how we will develop the physical infrastructure on the site itself. I mentioned in that earlier slide that we have a 7-acre site at the northern portion of our 27 acres that's readily developable. Our plans are to base the first 2 converter stations on that site, with a 3rd converter station located south of Unit 40 in an area that is currently a parking lot. Next slide. The way we achieve this is by orienting our converter stations in a vertical configuration that is based on the designs for offshore HVDC converter stations. Put simply, if you can put a converter station on a jacket foundation in the middle of the North Sea in a vertical orientation, you can put a converter station in a vertical configuration on a parcel of land in Queens. This is a unique configuration. This is based on what we've heard from the other presenters, the very significant lack of industrially zoned waterfront real estate in New York City and the various constraints associated with acquiring that, namely that the real estate itself is very expensive. We have optimized this around the availability and cost of land to maximize power density on our site. And in so doing, developed a facility that allows us to be able to site on that first portion 2 converter stations, along with all the warehousing and office space necessary to support the operations of 2 1,400 megawatt offshore wind facilities, as well as all the AC infrastructure necessary to connect into the 2 Con Ed substations that we'll be tapping into. Next slide. In addition to that, we also recognize that our site is a very unique facility in being able to support the operations and maintenance of offshore wind. We have developed a comprehensive plan for using our existing quayside, which we currently use for moving several million gallons of fuel oil across the harbor every year, for a repurposing to support multiple offshore wind facilities operations and maintenance. The building I just showed you has the potential to accommodate enough warehousing and office space for 2 completely separate offshore wind generating facilities. And we have enough space identified on the site, as shown here, to be able to accommodate an SOV and up to 8 CTVs in combination with that to support up to the full operations and maintenance of the offshore wind facilities interconnecting at our site. We see this as a benefit to the offshore wind project very clearly in being able to establish a O&M hub that creates jobs in New York. But it goes further than that. This goes to our commitment to effect a just transition. Over the last several years, we have developed a very comprehensive training program and a certified training facility on our site. So part of our plan includes making available our existing workforce to be able to transition out of working on fossil generation and into working on new renewables. And within the context of New York, being able to provide a just transition for the women and men of the unions who have been keeping the lights on in New York City is a very important and powerful element. So that's it. Next slide. With that, I want to thank you very much for your time. Any questions, please direct to any follow-up questions after this. Please feel free to direct to Jamil Khan, who's our project director, and I'd be happy to take any questions on the call here today. Thank you.
Great. Thank you, Clint. Okay, we do have questions, I can't say trickling in, flying in a little bit. Bear with me a sec.
No worries.
Here's a question that covers a lot of ground, is actually kind of several sub questions. So we'll start at the top. If your project requires retirements of existing generation, do you have a timing? What's the timing for those retirements?
Obviously, maintaining reliability is of chief importance, and we've spent a great deal of time with the New York ISO on discussing exactly how this will work. So I would say that there, and the NYSERDA would acknowledge this, that there is a difference between CRIS rights and unit retirements. Our plan is to commit contractually to proceed with a fossil retirement that would take effect simultaneously with the commencement of commercial operations of the new generating facility interconnecting at that site and making use of the CRIS, which would be assigned to that. However, our design of the AC interconnection facilities is such that if the NYSO and the Department of Public Service deem that a unit or units at Ravenswood are necessary for a period of time to maintain reliability, that the NYSO and the DPS could retain those units under a reliability must run energy only arrangement with the new interconnecting offshore wind facility taking possession of the CRIS rights and having the ability to interconnect and inject at the site. So we are simultaneously managing multiple different trade-offs. One is ensuring that the wind farm itself has the CRIS rights that it needs to demonstrate to NYSERDA that it has deliverability. And on the other hand, we're also demonstrating to the NYSO and the Department of Public Service that they have this backstop assurance of being able, in the very worst case for reliability, to be able to ensure maintenance of one of those units if necessary.
Okay. So I get it that, you know, that there's a high degree of coordination among the different, you know, in this transition. The questioner asks whether there will need to be site remediation between demolition of any existing facilities and construction of new?
There will need to be a very comprehensive environmental review, and then the outcome of that environmental review will determine what remediation, if necessary, is required on the site. So that will be the prerogative of, among other agencies, the Department of Public Service, the DEC, and any of the federal agencies that will be involved in this review. I think the benefit here is twofold. Number one, we own the site, and as of May of next year, the 7 acres that currently hosts the peaking units will be available for redevelopment. And number two, we have undertaken a very comprehensive set of characterizations of the site, including geotechnical and other borings on the site to characterize exactly what's there. So we do not see any fatal flaws whatsoever in the ability to permit and effect a cost-effective construction of these facilities on our site.
Okay. Looking at the existing interconnection, do you expect upgrades to come into compliance with current interconnection criteria as part of this?
Obviously, we're talking about doing something that is new. We are using a HVDC transmission facility to deliver offshore wind, and we're assigning CRIS in what will be a repowering and an upgrade of those CRIS to correspond to the wind generating facility delivered over DC. The short answer is that's ultimately the discretion of the NYSO as part of the interconnection process. However, the fact that we are assigning CRIS into this gives us a high degree of confidence that if there are any upgrades, they will be significantly mitigated because the site already has the CRIS and it's been in use for quite some time.
Right. Can you clarify, Clint, which units you plan to retire at Ravenswood?
We have 3 1960s vintage units. Those units remain necessary for reliability for the near term. However, as the NYSO and DPS have pointed out, the plans to bring significant volumes of offshore wind into Zone J, along with the recently awarded Tier 4 projects, create some headroom that allows for the retirement of a certain volume of the oldest generation in New York City. And indeed, in her State of the State at the beginning of this year, Governor Hochul made clear that her ambition is to put forward plans that will lead to the retirement and replacement of, I think in her words, the oldest and the dirtiest of the generation in downstate New York. So our plan is to retire and replace all 1,800 megawatts of our 1960s vintage generation. That would be units 10, 20, and 30 over time and phased in with the new resources delivered into our site over HVDC that can replace it. But we're contemplating a comprehensive transformation of the Ravenswood site from that of being the largest fossil generating facility in New York City to one that replaces all 1,800 megawatts of those 1960s vintage units with renewables delivered over HVDC from a variety of other sources.
Okay. Couple of questions about the kinds of studies you've done to date. For example, were deliverability studies performed, curtailment studies, cable routing studies? Have you done that kind of work?
Oh my goodness, that's besides running the plant, that's all we've been doing for the last 2.5 years, Liz. We have invested very considerably in doing not just cable routing studies, but actually putting vessels on the water and doing vibracores to map out every single inch of the route from the OCS through state waters, through the Narrows, navigating each of the individual infrastructure crossings that we need to get across to get all the way up New York Harbor, up the East River into our site. And so we have reams of data to support this. And when I say that we're going to be submitting an Article 7 later this year, there are two different types of Article 7s, right? You can throw an Article 7 in and then do supplemental data collection later to advance it. Or you can take the approach that we did at Deepwater with the South Fork project, where we had lots of data that we submitted because we did the surveys in advance. We're taking the latter approach here, in that we have led with science and led with engineering, and we've invested in actually gathering the on-the-ground data about every inch of this route from the OCS into our site. And with that data, then we've engineered a set of cable trenches, including the installation methods and the types of cables that are necessary within those, accounting for the particular thermal resistivity of the soil to ensure deliverability into our site itself. And then on the site, we've undertaken comprehensive engineering of the structure of the building itself, as well as the layout of the HVDC and AC equipment within that, with a major OEM as the basis for that, and engineered the offshore wind O&M warehousing space with input from a major European. And then in addition to that, we've undertaken what you would anticipate as all of the interconnection studies necessary to demonstrate that we can inject into the grid. And we have 3 separate interconnection requests in the queue, all under the entity Queensborough Development, LLC.
And is any of that work publicly available?
Not yet.
Not yet. Let me see. How about, and I asked this, we had this question with our previous 2 participants. What is your, I know the coordinate, the vision is tied to the reliability issue, but what is your project schedule, if you can, what is your targeted in-service for this, if everything goes the way you're expecting?
Yeah, we think the long pole in being able to execute this project is the approval of the BOEM COP, not the Article 7. So I'll walk you through the schedule as we foresee it. We will be submitting our Article 7 later this year. Obviously, we'll have to go through the deficiency notice and cure process. We anticipate that by some point mid-year, next year we'll have a fully we'll have a determination from DPS that the application is complete, and that thereafter it's a pretty straightforward schedule for being able to get through the completion of the certification of the project. So we do believe that this, if it were just limited to Article 7, you could see this project be in service by potentially as early as 2028. We also think that just looking at BOEM's queue of projects, that the BOEM COP approval will likely push it later than that. So suffice it to say, we do not anticipate that this project will be a gating item. In fact, we think that the work that we've done and the fact we'll be submitting an Article 7 prior to the end of this year means that we've significantly de-risked the overall development for our partners.
And Clint, just for me, the Article 7 would be for the cables to the site, or what will be the subject of the Article 7?
Article 7 will be for the comprehensive transmission facility originating in a offshore wind lease area.
Okay.
And terminating at the Ravenswood site. So
Okay.
obviously Article 7 has jurisdiction over everything in state waters.
Yep.
Obviously, you're going to want to know as well the origin of that. And so, it'll
Okay.
define a complete project.
Yep.
And it'll provide all the necessary data within state waters.
Okay. And have you developed cost estimates?
We have developed cost estimates, and we are currently in a process where we have run competitive RFPs for each of the major scopes of the transmission facility, which will be completing by mid-October.
Okay, great. I'm not going to ask you to share them. I think there's been a kind of universal no thank you on that subject here. Let me see. There are a couple of questions about the site in New Jersey. Is there a concern about if there's a subsea cable being installed in New Jersey waters, will you need coordination and a permit from the state of New Jersey?
You will need coordination. I mean, look, an offshore wind project interconnecting in New York is going to require coordination with the state of New Jersey, if for no other reason that you're going to need a CZMA approval. Our route does contemplate certain portions of that route going into New Jersey's territorial waters, and we've been engaged with the applicable New Jersey entities and have accounted for that in our overall planning.
Okay. What is the what is your message to offshore wind developers who might be interested in accessing the project? What are your proposed business commercial arrangements?
Yeah, well, look, I think our view is that, you know, first, New York has been the absolute leader in New York, in the U.S. in being out with kind of big, ambitious goals. We understand that New York has been, aggressive in putting forward really thoughtful ways of procuring offshore wind. And so my message to the wind developers is that New York needs a lot of offshore wind to get to our goals, right? New York, you know, I have a job right now because New York enacted the CLCPA that says that by 2030, we need to be at 70% renewables. And by 2040, we need to be at 100% renewables. And when you're the owner of a big fossil plant, those can either be really big, scary challenges, or they can be big opportunities. And we've chosen to make those the opportunities. Now, we acknowledge that to get to 100% renewables, we're going to need a lot of new stuff. And our internal modeling suggests that we're going to need way more than just 9,000 megawatts of offshore wind. So my message to the offshore wind developers is that we are all going to be needed, and that it's going to take multiple projects, multiple different interconnection places, that there's possibilities for every one of the folks that's on this call today to be successful. Our plan, as we've in various discussions communicated with many offshore wind developers, is to be a partner and to help bring those projects to reality. And so we intend on having bespoke engagements with individual offshore wind developers and helping them bring their projects to fruition, obviously for NYSERDA to consider in the upcoming 2022 and potentially future solicitations. So I think I know most of the folks at the developers. You've obviously got my contact information. If anybody's got kind of further questions, they're happy to have discussions online or offline. But our focus here is really to try to be a partner with New York State to help facilitate this transition to 70% by 30, 100% by 40, and to demonstrate to the world that there's a profitable business model in transforming fossil generation into hubs of renewable energy.
Let me just pause there and check with my colleagues. Greg, do we have a time check?
Yes, we have time for one more question, Liz, and then we'll close up.
Okay, let me try to find you a doozy. Here's
Thanks,
one.
Liz. Appreciate that.
A couple of people have asked me to ask you and the other developers here whether you will have NYSO queue positions by the time the OREC RFP closes. So if you could answer that, and then maybe the prior presenters just remind us of their status as well.
Oh, yeah, absolutely. Well, I think I saw that at least one of the prior presenters had published their interconnection queue positions. But yeah, we've had interconnection queue positions out there for for quite some time. If you're looking at the interconnection queue itself, it's listed under Queensborough Development as the entity, and their queue positions 1365, 1366, and 1367. We got a few others in the queue as well.
Okay, and any of the other teams want to respond to that?
Hi, Liz. This is Frank Defemia from NYPA. So our Richmond Spoke project is queue position 1308.
Okay.
And King Spoke is queue position 1435.
Okay. And Avangrid, I think I heard you weren't in the interconnection queue yet, but do you expect to be by the time the RFP closes?
Perhaps they've dropped.
Oh, no. They might have. Everybody is overscheduled. Okay, all right, so we have not quite a complete answer there. I think we'll wrap with that, Greg, and I'll just say thank you to everybody for bearing with me as I was navigating through the questions, and appreciate your participation today. I'll leave it up to you, Greg.
Great, thank you. And thank you, Clint. Thank you, Frank. And thank you for the Avangrid team. Really appreciate the information you imparted today. And a very special thank you to Liz for facilitating that Q&A. I know it can be a real challenge reading through the list of questions as they keep flowing in.
Keeps me on my toes.
My apologies. Can you guys hear me?
Yes, we can.
My headset ran out of batteries at the right time. So apologies for that. We are ready to be on the queue at almost any time. So we have all the studies and drawings ready for the application. So
okay, so you could be.
We could be.
Okay.
Yeah.
Okay, very good. Thanks for that, and mind your batteries.
Thank you.
Thank you, Fernando. Great, and thank you all for participating today. We appreciate you joining our Offshore Wind Interconnection webinar. Just a reminder, the slide deck and the recording of the presentations we've made available on NYSERDA's website. It'll probably be next week when we get the recordings back from the WebEx team. It'll be posted under our offshore wind page under focus areas, transmission in New York's electricity grid. Alternatively, you can just Google NYSERDA offshore wind grid and it'll pop up for you. We're planning on having another public webinar on offshore wind cables constraints assessment, the RFI that we have on the street that I spoke about previously. It's tentatively scheduled for the second week of October. An invitation will be going out later this week with more details, but we'd be super interested in the feedback that any of you have on that RFI that's out. Again, thank you all for joining us today and have a great afternoon.